Hello. In this video, we're going to be talking about probability. So the probability of an event E occurring is assigned a value somewhere between 0 and 1, including 0 and 1, that relates the frequency of that event's occurrence. So a sample space, S, is going to represent all the possible outcomes of some phenomenon. For example, when we flip a fair coin, the sample space is either heads or tails. There's two possible outcomes. An event is a subset of S, meaning that can only contain elements from S. So the event of flipping a fair coin has two possible outcomes, and the event E only has one element based on what the outcome is. It's either a heads or a tails. Therefore, the event E is a subset of the event S because it only contains the elements from S. So to calculate the probability of an event E, given some non-empty, finite sample space S, what that means is there are some elements in S, but they are countable, number of elements, and they all have equally likely outcomes. So to calculate the probability that event E occurs, you take the number of elements in set E, and you divide it by the number of elements in set S. So for instance, the probability of flipping a heads, well, the only way that happens is to flip heads. So we have one outcome that would be a successful event. Out of how many possible outcomes? Well, there's two, heads or tails. And that's how we get the probability that we flip a heads is 1 out of 2, or the probability we flip a tails is also 1 out of 2. And again, notice that 1 out of 2 is 0.5, which is between 0 and 1. Let's do some more examples. In the first example, what's the probability that we toss two tails in a row on a fair coin? So the probability of two tails. Well, if we flip a coin, there are how many outcomes? We can go heads, heads. It can go heads, then tails. We can go tails first and then heads, or tails and then tails. So there are 4 elements in the sample space, and how many of them would give us a successful outcome? Well, only the 1. So that's a 1 out of 4 chance for that probability. Number 2, drawing an ace from a standard deck of 52 playing cards. So if you have 52 cards, so the probability of drawing an ace, there are 52 cards to pick from, so 52 is going to be our denominator. That's the number of elements in the set S, all 52 cards. Now, how many of them would be a successful choice? Well, we have the ace of spades, we have the ace of diamonds, ace of clubs, we have the ace of hearts. So there are 4 different aces we could choose that would be successful, so we get 4 successes out of 52 options. And we can simplify this fraction. They're both divisible by 4. 4 divided by 4 is 1. 52 divided by 4 is 13. So there's a 1 out of 13 chance we draw an ace out of 52 cards. In number 3, what's the probability of rolling a sum of 10 on 2 different fair 6-sided die? So we're going to roll 2 die, and we're going to get a 10. Well, on one die, I can get anywhere from 1 through 6, and on the other die, I can get anywhere from 1 through 6. So there are 6 times 6 potential outcomes, so 36 there are 36 elements in our sample space. We can talk about getting a 1 and then a 1, a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, and so on. There's 36 of them total. Well, how many of them would be successful for us? Well, we could get a 6 and then a 4. We could do a 5 and then a 5, or we could do a 4 and then a 6. And that's it. Those are the only 3 options that add to make 10 on 2 die. So there are 3 options out of the 36. And again, we can simplify this I can take a 3 divided by 3 to get 1. 36 divided by 3 is 12. So there's a 1 out of 12 chance of rolling a 10. In the last example, what's the probability that we eat sausage pizza given a choice between pepperoni, sausage, and cheese? The problem with this is even though we have a countable sample space, we have 3 options here, pepperoni, sausage, and cheese, they're not equally likely outcomes, just based on preferences. Some people have a bigger preference between the 3. Personally, I'm not a big pepperoni fan, so that one is almost a non-existent chance that I would have that. I would be more likely to have either the sausage or the cheese. So this is unable to be determined. We would need a lot more information on that. Okay, that's your crash course on basic probability. For now, we're done.